Today we are working on section 3.1, which is graphing systems of equations. So graphing a system just means that we're putting multiple equations on a single coordinate plane. Before we get started with graphing a system, let's go ahead and talk about the format that we'd like to have our equations in. Normally we want our equations to be in slope-intercept form to make it easier for graphing. So that's y equals mx plus b. M is our slope. It is our rise over run. This is how we find the rest of our points after we have graphed our y-intercept. Our y-intercept is the starting point vertically, which is up and down, on our y-axis. So looking at this format, I'm going to use two different colors to be able to graph these just so you can see the difference between them. So question number 1, we have y equals negative 3x plus 4. Our y-intercept is plus 4, so we're starting up 4 on our graph. And our slope is negative 3. But to make it a fraction, I'm putting it over 1. This means that we're going to go down 3, right 1 from our starting point. I'm going to continue this same pattern of down 3, right 1 until I have filled my graph. Down 3, right 1. Down 3, right 1, and so on. I also want to fill it in the other direction, so I can go up 3, left 1. And then I want to connect these with a nice straight line. Okay, so that's for our first line. Our second line, our y-intercept is this minus 2, so we're going to start down 2. Our slope is 3, so we're going to put that over 1, so that means up 3, right 1 from that starting point. Then we're going to go down 3, left 1. Connect them with a nice straight line. And this is the format we're going to stick to. So let's go ahead and try that same thing for number 2. So for the top one, it's already in y equals mx plus b. This is starting at a positive 2. Since there's nothing in front of x, it's like having a 1 in front of x. So that's like 1 over 1. This means we're going to go up 1, right 1, and continue doing that until we fill our graph. We are also going to go down 1, left 1. Connect it with a nice straight line. Now the one below it is a little weird. This doesn't have a y value, so we can't put it in y equals mx plus b. This means every single x value equals negative 3. So if we go to where x is negative 3, that's here. And if every x is negative 3, that would be here and here and here and so on. This shows every x value being negative 3. So when x equals a number, that's actually going to be a vertical line. Okay. What if it's not in that format? What if x and y are on the same side? Well, we want to get y by itself. I'm going to show you two different ways to do that. So x minus y equals 3. So the first way is how we would normally do this. We want to get y alone, so we'd have to subtract x to the other side. You'll notice I'm not lining it up with that 3 because the 3 does not have an x. We still have negative y, and I'm going to rearrange it so it's negative x plus 3, just because I want my x then my number. But that's not it. I don't want negative y, I just want y. So I have to separate this negative from the y, so I'd have to divide every single piece by negative 1. That means I'm left with y equals x minus 3 as my equation. So that's the first method, is by removing everything else from y. Second way, when I have a minus y, to avoid dividing everything by a negative 1, I can actually add it to the other side. So that's a big or. So when we do that, we're left with x equals, and again, I'm going to do y and then the plus 3. But I don't want 3 with the y, so to move it, I have to subtract it. So we're left with y, I'm in x minus 3 equals y. You could put the y first or last, it doesn't matter. So regardless of which method you use, you get the same answer either way. Okay, so top one is y equals x minus 3. Bottom one, if I rearrange, I can add y to both sides. And that's a minus 3. And then I have to add 3 to both sides. So this would be 7x plus 3 equals y. All right, now time to actually graph it. My starting point for the top one is down 3. And my slope is 1 over 1. I'm going to go up 1 over 1. I can also go down 1, left 1. And connect with a straight line. For my second one, we're starting up 3. My slope is 7, so that actually means 7 over 1. So from that point, I'm going to go up 7, right 1, and down 7, left 1. At that point, I can go ahead and connect using a nice straight line. So if you need practice rearranging, I highly suggest pausing the video and seeing if you get the same thing I do for number 4 when I rearrange. So y is equal to negative 4x plus 2. It's because I subtracted 4x from both sides. And y is equal to x minus 3. For the pink line, our starting point is up 2. Our slope is negative 4. So that means down 4, write 1, and keep going. Oops. I can also do the opposite and go up 4, left 1. Then connect with a nice straight line. For my second equation, I'm starting down 3, and my slope tells me to go up 1, right 1. And down 1, left 1. Connect with a nice straight line. I want you to try 5 and 6 on your own. I'm going to go ahead and put the answers here, but no explanations. If you need to, you can go ahead and follow along as I do them. Hopefully that made sense. Number 7 is a bit different. So you'll notice in the top one, we have y equals -5. That means every y value is -5. So if I go to where y is -5, that's down here. And if I continue putting dots where y is -5, that's all of these here. So when y equals number, it's actually going to be a horizontal line. Now, for this top one, subtract 5x from both sides. So 4y is still there. We have a -5x and a -20. Next, we have to divide everything by 4. So y equals -5/4, x -5. So we're going to start down 5. And our slope tells us to go down 5, right 4. We can also go up 5, left 4. And connect those lines, or dots, excuse me, to make a straight line. Number 8, also a bit different. If we subtract x from both sides, we have 7y equals -x. If we divide by 7, y equals negative 1 over 7 x. The bottom, if we add 8y, subtract 22, and then divide by 8, this one doesn't come out nicely. We'll talk another day about how to do questions like this.